Hello and welcome back. Today we will learn how to mesh two gears together using the DMU Kinematics workbench in CATIA. We will be using these existing gears that we designed in a previous video. If you have not seen that already, please check it out. I'll be linking it in the description and somewhere on screen. As well as this simple support that I have designed off screen quickly, just to not waste any time now. By the end of the video, you'll learn how to create this mechanism and design this simple gear joint in CATIA, and you'll be able to run this wonderful simulation of the two gears working together and meshing correctly. Okay, so to get started, you'll throw these parts together in a new assembly like this and begin to position them. So we have the small pinion gear, the big one, and the support. We first need to put them somewhere on this surface and put them in the right position. Now this step is not entirely necessary, but it's very helpful. It's very helpful due to the initial positioning, so that we don't make the teeth clash. So you see you have a small clash here. What you need to do is put the compass here and start turning it so that it barely contacts. I mean, I don't know what kind of requirements you have. Maybe you need to be a little more precise, at which point you have to make sure the contact is better designed, but I think this should be enough in most cases. Right, and now you switch over to the DMU Kinematics workbench and start putting constraints. As you know, the mechanism which we're going to create now will always require a fixed component, which is going to be this one. And then you need to, in order to put the gear joint, you see that you will need to design two separate Revolute joints. So you have the first Revolute joint, which is going to be this one. We need the line, and we need the plane. Hide this. And click angle driven. And the mechanism can already be simulated, but we don't want to do it now. We want to put the other one as well. The two lines and the two planes. Of course, in a real mechanism, you would not want this friction here between the gears. This is just an example. Okay, so now that we have our two Revolute joints here, you can see we have 1 degrees of freedom because they are not linked together yet. We will put our gear joint where we have our first Revolute and our second Revolute, and we want the direction to be opposite. I don't know why it's not opposite by default, but you always want it opposite when you have two gears like this. The ratio is going to be -1 because it's opposite, but we will change this shortly. And we have our Revolute, okay, angle driven for first Revolute. And now the mechanism can be simulated and we have 0 degrees of freedom. One thing I did not mention is this distance between the gears. This, we have not talked about it in the previous video. This is actually going to be calculated here. It's the A value, distance between the two gears, and it's calculated like this: Z1 plus Z2 times the module divided by 2. So you add the number of teeth together of the two gears, you multiply it by the module and divide it by 2, and you have your distance. And one thing I wanted to note that I did made a little change to this formula here because these teeth were slightly clashing. Sometimes interference happens. You might need a profile shift or to slightly adjust the thickness of the tooth depending on the module and number of teeth. So I just subtracted minus 0.1 degrees from this, and it works perfectly. Good. Now that we have our mechanism, you can see that it does not work well because it does not have the ratio. The ratio is simply Z1 divided by Z2. That is the number of teeth on the small gear divided by the number of teeth on the big one. So as far as I can remember, it should be minus 25 divided by 40 or something like that. Alright, now if you run this, you see it meshes perfectly without clash and without anything, without any issues. Alright, if you want to do a simulation, you do it like this. You go to the 0 position. This is basically the time, 1 second. Go to the 0 position, you modify this like that. You go to this one, should be something like 0, modify it, and then insert a new position, and then you're done. It has like 3 positions, and then you have your simulation. Change the number of steps to make it run slower, and you have your gear meshing together perfectly. So that's been it for today. If you want more quick tips, leave a like and subscribe to my channel. It really helps a lot. Thank you, and see you next time.